problem number 1186, maximum subarray sum with one deletion. Given an array of integers, return the maximum sum for a non-empty subarray with at most one element deletion. In other words, you want to choose a subarray and optionally delete one element from it so that there is still at least one element left and the sum of the remaining element is maximum possible. Okay, note that the subarray needs to be non-empty after deleting one element. Okay, so let's first clarify the boundaries, like the limitations. Okay, so how long will be the given array? Okay, it's a large number and it will be at least one element. Okay, and how, like the so each of the element, like how small is it and how big is it? Okay, it will have negatives. Okay, so we may have like negative 2, then you will return negative 2. Or we will have like 0 and 1, and you will return 1. Okay, then okay, so for if we first ignore the deletion part, then for maximum subarray, yeah, we will have like, yeah, we will loop through every subarray that ends at nums I, and like the yeah, and when we are at nums I, then its maximum sum will be the previous array plus itself, or it can start over by itself. Yeah. And now let's add in the deletion part. So okay, so first of all, when I think of deletion, the brute force method will be, yeah, if we use the previous maximum subarray method, then we should like loop through every subarray and see. We should loop through every subarray and also the delete element, and check which, yeah, and we should check if deleted or not will have the maximum. And so yeah, but it's like too much, like many, like if every subarray and we have to check every element, then it will be yeah, like a large it will be a large computation. So I am thinking we can loop through every element of whether delete or not. So maybe like yeah, like the first example, like if we are at 3, then its maximum subarray will be the max sum at 0 added by 1. But now if I delete 3, okay, so so when I delete 3, then its maximum sum will be the previous array without deletion. Okay, and when we are at 0, its maximum sum without deletion is the previous array plus itself, or started by itself. And we can add another option, is that delete itself. If deleted, yeah, I was thinking like if delete 0, maybe 3 can be added to the previous one. Yeah, I think it's kind of the same as the previous problem. So yeah, if you are larger, like if 3 is larger than -2, then if we delete 0, it can combine with the previous array. So we can say that, yeah, if can delete, then then the max sum of subarray ending at nums I will be the max sum of subarray ending at nums I minus 2 plus nums I. If nums I is larger or no larger, yeah, we can just check. There's no if. I am thinking that, yeah, if like this, then should we for loop like yeah, so it will be ending at nums I minus 3 plus nums I. Okay, so it seems like oh, yeah, for this we delete this element, and for this, if we add like I minus 3, then it will be, yeah, like this, yeah, so this will be nums I minus 1 plus nums I. Okay. Okay, so this is like a large, huge computation, since if we do so, then for every nums I, there will be, yeah, like n computation, and there are n subarrays, so it will be n with the power of 2, so it will be too much. Okay, I came up with another solution that will be like yeah, we can first calculate maximum yeah, like we can calculate all of the prefix sum, and yeah, that's a way. I'm thinking of like a dynamic programming solution, since yeah, it seems like it is looping through the same problem. Okay, I think we will still first use prefix, sum, and suffix. So yeah, like now for nouns I, we will have the prefix I think we will first do the large computation thing, and then let's see what we can optimize. Okay, so for that, it is a recursion, so I would use DFS. So for DFS I will have it will be defined as the maximum sum of subarray ending at nouns I. Yeah, let's see if we can use one parameter to finish this. So it would be maximum between, like, you can select yourself, start by yourself, or you can, if without deletion, then you can do it like, it's DFS I plus 1, the previous subarray, plus nouns I. This is without deletion. And if delete, like, we can delete nouns I, we can delete nouns I minus 2, we can delete okay, so for DFS I, with deletion, it will be maximum of, like, if delete nouns I, and so the sum will be DFS I minus 1. If delete nouns I minus 2, then it would be DFS if delete nouns I minus 1, then it would be DFS I minus 2 plus nouns I, and like I minus 3. If delete nouns I minus 2, then it will be nouns I minus 1 plus nouns I. Okay, so this thing, like DFS, I think this is like DFS J plus nouns is delete I is deleted, so like J plus 1 is deleted, so it would be J plus 2 with I plus 1. I'll say maybe like can change this to j, and this will be j minus 2. Yeah, so this is with deletion. But I think like from not sure if we can combine these two, like okay, maybe let's just try. So yeah, the time complexity will be big O and with the power of 2, and n is the length of array, and the function will be df as I. Let's talk about the boundaries later. Okay, so return, yeah, like the whole thing. Nums I df as I minus 1 plus, I'm thinking like, okay, I'm not sure if this, and also the for loop thing, so yeah, it will be df as j minus 2 plus nums j I plus 1 for j in range I plus 1. But j will be started from 2, and yeah, it would be started. It can be started from I minus 1. That will be I don't think this is included. Let's check. Yeah, since the maximum of j is I, then okay, so it will have I minus 2. And then it will be like I minus 1. Okay, so there's no dfs I minus 1. And then that's it. So if I is like 1, it will not run. We will say default is yeah, we will first add this, then let's see. Default will be negative yeah. Okay, and the boundaries will be if I is smaller than 0, then return, return negative if, since it's invalid. Okay, and return, we have to calculate every subarray. So for I in range n, not sure if if I give it like a 0, will it be valid? Why I cannot give a default? Or it should be like this. Okay, then if it's not valid, then that's stupid mistakes. Why does this maybe just remove? Okay. So it's parenthesized does not support between instance. Maybe let's do like empty. Okay. Oh, this is sum. Okay, this thing is so slow. And it's wrong. Okay. Why is it? I think we don't need. Okay, let's wait a second. We will have I minus 2 till 2. And for DFS 0, it will be. Okay, it will be itself. So why we have 4? I don't know where it comes from. So I think it will be like 3 adding with 1. But or is it coming from like J is J will be 0. I think it would be better we'll have prefix. So yeah, since we are all calculating prefix and suffix is here, so for each like okay, we'll have for each subarray ending at nums I, yeah, we will calculate all the possible combination of its sum. Okay, I want to stick with this brute force approach and fix this. Then we will then talk about optimization. Okay, so for this, maybe we can try like reverse way. So it will be started from I, and it will be ended at 2. Is 2 possible? If 2, then it will be 0. and 4 zeros, it will be itself plus the sum array will be, the sum will be array from index 2 to I plus 1. Yeah, kind of correct. I'm thinking that maybe some DFS or stuff is contained, let's say, it is not pure already. Or can we delete I? Oh no. If we start our J at 1, then DFS J minus 2 should be 0. But but if this 0, no. Okay, now so we should have negative things, but sometimes 2 I will say 1. If this is 1, then if J is larger than 2, I'll return 0. Like this. Oh, should be negative. check the solution, and yeah, it seems like I have to redefine the definition of the state. So yeah, since like for the error comes from I mix different state with each other. So for this 4, it may come from like the previous state may have already delete the element, but at current subarray, there's no idea whether the before array has deleted, and if it delete, then it will use like the delete count will be larger than 1, so it is incorrect, and so we have to add the delete count into a state. So that's we have to redefine the definition. So okay, and okay, so first, if cannot delete, then the maximum of subarray and ending at nums I will be the previous maximum ending at nums I minus 1 plus nums I, or start by ourselves. That is nums 1 and nums I. If can delete, the maximum sum of subarray ending at nums I will be like we can choose where to delete. So we can delete nums I, or we can delete at the previous elements. So if we can delete the maximum, okay, so if we don't delete at nums I, let's say if can delete delete at num side. Maximum Subarray ending at num side will be the previous array. It cannot be deleted for the previous array, so will be or if we can delete, but we don't delete on num side, but at previous ones, then the maximum of subarray ending at nums I will be previous maximum and can delete. Okay, so then we will have our recursion DFS I with D, delete or not. So it will be the maximum of subarray ending in nums I that can delete or cannot delete an element. So DFS D has only two options. There is cannot delete and the other one will be can delete. So if DFS I 0, then it will be DFS I minus 1, max between DFS I minus 1 plus nums I or itself. And if can delete, then it will, this should be 0. It will be, there are two options. If we don't delete nums I, then that will be DFS I minus 1 with 1, since we can still delete in the previous array. And we will plus our current value, if we don't delete on nums I. Let's check. And if we delete nums I, then it would be DFS I minus 1 with 0. Like the previous state definition, it kind of like this is the state of cannot delete. It makes together. So Yeah, it's half correct. Okay, and for time complexity, since D is small, it's only 2, so we will have O, big O N. And then we will have the length of array as n, and DFS will be D, ID. We will talk about boundaries later. Then if D is 1, then return maximum DFS. Let's copy. And else, if D is 0, then return this. Yeah, and for the boundaries, okay, first of all, I don't want I minus 1 is out of boundary. So for I smaller than 0, I think I would have, yeah, since there's negatives, if I return 0, then this, yeah, like if this is 0 and this is 0 too, then it will pick 0. But I want nums I, so I will do like if I is 0, then return nums I. Because it has to pick 1, like, yeah. Let's see how it goes. Oh, sorry, this should be 1. Oh, terrible mistakes. Yeah. Oh. Oh, it says we still have to, yeah, we have to add this, since yeah, we have to compare. Okay, yeah, because since if we use DFS I1, then it means it can delete, yeah, it should delete 1. But if don't delete is also an option, maybe it can get better. Yeah, if all the numbers are positive, then this will be better. So yeah, we have to add this. Yeah, and a catch. Okay, great. Then we will turn it to a matrix. A for loop iteration method. Then we'll first have matrix that will be maxsum. So we'll first have I'll say invalid value, and for D there are 2 columns, and then for I we will not use dummy node, so I'll have n as the length, as a row, as n rows. Then we'll start our for loop. N. Okay, so when D is 0, it equals to max I minus 1 0 or plus the current value and or itself. Oh, it's array. Fall in love in nums. Okay, then if maxsum I when D is 1, then it will be maxsum max with maxsum I minus 1. If 0, then you should add yourself. And if 0, then it means we delete ourselves. So it will remain the previous array, the previous sum from the previous array. Then another option is to don't delete ourselves, so it will be maxsum I minus 1 with 1. We will leave the chains for the previous array, but we have to, since maxsum I1 means the array, the maximum sum of the array ending at array I, ending at nums I array I. So we have to add ourselves. Okay, then we will have a value to keep track of the maximum sum of each iteration. So I'll have non-zero as the default, since this should have default. For max 0, we will have non-zero. And we will start from 1, since we don't want I minus 1 to be out of bound. And at each iteration we should compare with each other. So this will be maxsum I0 and I1. Okay, then return answer. It's so stupid. Okay, let's see. There's no nums. Okay, great. Okay, cool. as usual, we can optimize the space from the array to constant. So we can have like max d1 equals array equals max d0 equals answer equals array 0. Okay. Then we can have copy this to replace for 0, replace this, okay, then I think we have to do this in one line, since if we don't do it, then this should be this will be the value of this, but we want the clean value. So this will be replaced, so it's not pure, so we will have it here. This will be here. Okay, let's go. Great.